Okay, good morning to everyone. In the previous class, we were discussing about the BOD exerted and BOD remaining. So we'll take the example how this BOD exerted and BOD remaining are in practical applications. So we have taken one example. In that example, they said that the BOD of the sewage incubated for 1 day at 30 degrees centigrade has found to be 200 milligram per liter. Means at 30 degrees centigrade for 1 day, if they have kept it in the incubator, it was found that 200 milligram per liter. The sewage sample they took it, they put it in the BOD bottle and they placed in a BOD incubator. So what they are asking is that what will be the 5 day at 20 degrees centigrade BOD, and assume K, that is the deoxygenation constant, that is 0.12 per day at 20 degree centigrade. See now the data whatever they have given. So the first day BOD at 30 degree centigrade, that is Y1 at 30, this is very important, that is equal to 2. Now maybe you will be confused with the L and Y value. Now with this example you can say that it is a BOD exerted for 1 day. It is exerting 200 milligram per liter. Means you can say if I keep it for 1 day, the BOD will be 200 milligram per liter. So if I keep it for the second day, the BOD will go on decreasing because the DO will go on decreasing. The BOD value will go on increasing. Means the curve what I have drawn in the previous case, that is the BOD exerted, that is the Y. So Y value will go on increasing as the time progresses, but the L value will come down as it. With this example you can understand. So now for first day it is 30 degrees centigrade, Y is equal to 200 milligram per liter. So then 5 day BOD at 20 degrees centigrade, they are asking why 5, but that too in 20 degrees centigrade, not in 30 degrees centigrade. So if they reduce it for 20 degrees centigrade, that BOD incubator temperature, then what might be a 5 day BOD well, that they are asking. Then a K, that is the K what we have taken, that is we have Y formula that we already discussed, that is L naught minus LT. Then we have used L is equal to L naught e to the power minus KT, that we have used. Then formula we derived it 1 minus e to the power minus KT. So this K value at 20 degrees centigrade they have given, but we need the value at 30 degrees centigrade. Then how exactly it can be calculated? So let's go with the solution. To find out require K 35 degrees centigrade. We don't want K 20 degrees centigrade. K they already given. As I already discussed that in the previous class, K 20 value will be given. Suppose if the K 35 if they want, you have to calculate using this equation. So first find out the value, that is by assuming theta value as 1.047, then K at um, 30 degrees centigrade, that is equal to K at 20 they have already given, that is 0.12 per day, always it will per day, into theta, that is 1.047, then that is T minus 20, that is T minus 20. So K at 30 degrees centigrade is 0.12 into 1.047, that is 30 minus 20. Then the K value become K at 30 is equal to 0.19 per day. So then the first stage BOD, that is YT, that is given by the formula called YT is equal to L naught minus LT. Then L naught is equal to L naught e to the power minus kt. If you take the logarithm of if you take the logarithm of in place of e, if you take to the power 10, so then first we'll convert this into 1 to the power e to the power minus kt. So then L naught 1, if you take the log scale, that is 10 power minus kt to the power to the base 10 if you convert it. So then if that is the case, then substitute uh, the yt, that is equal to L naught 1 to the power minus 10. So we have to find out the L at 30. So L at 30 is given by this formula. If you take the reverse, you just interchange this to this. Okay, it will come down and it will be the denominator, or you can convert it into this way. So L is equal to yt minus 1 minus 10 to the power minus et. So then if you want to find out this, substitute the value here. This you will get it 200. Substitute, it is already given for the first day. Suppose if you want to find out for the fifth day, that is T1, for the first day itself, what will be the first, before that, before going for the fifth days, first calculate what will be the BOD remaining at first day, that is L1, 1 day. So this is nothing but you have to use this equation. Once if you use that equation, you are getting 564.42. So then you got LT. Then with this LT, L at 20 degrees centigrade, that can be calculated with the help of the um, other formula called uh, L at 20 degrees centigrade. This can be calculated with this formula, because we require L at 20. So then you can use the above equation. This is a standard equation. That is a standard equation, that is equal to LT, L of 20. That I have not given the formula, but this is the RNA's equation, one more form, 0.6. So LT we already calculated. We don't know L at 20 degrees centigrade. So then T we already know. Then with this you calculate L20 first. Then L20, that is equal to 470.35 degrees centigrade. Now you can make the difference between these two. BOD remaining at 30 degree centigrade and BOD remaining at 20 degree centigrade. At 20 degree centigrade it is lower, at 30 degree centigrade it is higher. We'll analyze this problem in other way also, how exactly this temperature is going affecting for BOD remaining. Suppose if you want to find out for the fifth day, we'll coming back to the fifth day. So then Wi-Fi 20, that is equal to L20, this formula is already there. Then substitute all those values, then you will get the at Wi-Fi, so you will get uh, 352.2 milligram per liter. But why at first day, you can see At Y8, the first day it was 200 milligram per liter, irrespective of the temperature. Y5 at 20 degrees centigrade, it is 352, means first day it was uh, 200 milligram per liter, and fifth day it is 352.2 milligram per liter. So for this, we'll compare the L versus Y. L at one day, L at fifth day, Y at first day, and Y at fifth day. So you'll come to know that with this relation, the how exactly this curve and this curve is coming. Okay, this we will analyze the LT and YT value in the next class.